These are showing problems number 48, 37, and 17 in 2.2. So the first one here is a piecewise function. And in this piecewise function, we have two parts of it. We have this part here that is 2x minus x squared, but only when the x's are greater than or equal to 1. Then we have this other part that's a cubic. It's x minus 1 quantity cubed, only when the x values are less than or equal to 1. So I'm going to look at the function first here, 2x minus x squared. And I'm going to rewrite that because I prefer to write the x squared first because it helps me see that this is a quadratic, a parabola. And since this x squared is negative, I know it's going to be a downward facing parabola. I'm going to make a table of values though. And remember, my table of values, I can only use x's that are less than, greater than 1. So, but I'm going to put in 1 in there, and I am saying that it can't equal 1. But I am going to put in to see what would it be if I could put 1 in here, and it would be 1. But remember, it can't equal that, so I'm going to put in the graph an open hole at 1, 1, because that's where it cannot be. The next number I'm going to put in is 2. Now, 2, it absolutely can go into this function because that is greater than 1. And when we plug in a 2, we get 0, so I graph that point, 2, 0. And the next point will be 3, negative 3, and I graph that point. And the next one will be 4, negative 8, and I graph that point. The next one will be 5, negative 15, which doesn't fit over here on this graph. It doesn't go down far enough. So I'm just going to connect what I have. And remember, we started up here where it couldn't be at 1, but it's just past that. So that's why I graphed what it couldn't be and then everything beyond that. And that would be the downward parabola. Now we're going to look at the second part of the function, which is this cubic that has x minus 1 quantity cubed. And remember, that's just a cubic that has been moved over 1 unit. That's just to remember that that's what it's going to kind of look like. I'm going to make a table of values for that. And when I look at that table of values, I am going to plug in 1. And now, at 1, it could absolutely equal this because it says x less than or equal to 1. Since it can equal 1, then I know I'm going to put a solid dot at 1, 0, which is what I did here. I put the solid dot right there. And then I'm going to put in the next point, which is 0, negative 1. And I plug in a negative 1 and I find negative 8, and so I do that. And if I plugged anything else in there, it wouldn't fit. So that's as far as I could fill out the table. And then connecting the dots, I have this part of it. Now this whole graph, what you see here, is this whole piecewise function. So that's number 48. Let's look at the next problem. Number 37. This function has two parts. One is this x, which is a perfect diagonal function. It's the diagonal line. And x plus 1 is also a diagonal, but it's been moved up 1 unit. I'm still just going to use a table of values to figure this out. So for the first part of it, the x, I'm going to make my table of values. The x values that I'm going to use are 0, because it says equal to, are going to be 0 and numbers that are less than 0. So I start with 0, and I put that dot 0, 0. So because when I plug in a 0, I get out a 0. And now I'm going to be putting in numbers that are less than 0 over here when I fill out this table. So I'm starting with 0 and going to keep going less. So negative 1, and I plot that point. Negative 2, which gives me a negative 2, and I plot that point. Negative 3, I plot that. Negative 4, I plot. Keep plotting, and eventually I say, okay, I see the pattern, and so I draw the line. For the second part of this piecewise function, I have x plus 1. I make the table of values. Now, again, it says x greater than but not equal to 0. I still figure out what would it be if I could plug in a 0. And remember that it can't equal that. So I have this coordinate point 0, 1. And what this is, it can't equal it, so I'm going to use an open circle when I graph over here. And there is, if you can look carefully, I put an open circle right there. And that means it's not at this point, but it's going to be whatever follows past that. So I plug in a 1 because I'm using values that are greater than 0. A 1, I get a 2 I get a 3 I get a 4, and I keep plotting these points. 4, I get a 5. And if I kept going to 5, we get a 6. I keep plugging all those points in. And now I can see the pattern, and so I draw the line. And remember here, I have that open circle because it could not be that point, but it is the pattern just past that. So this now is a picture, this whole thing here is a picture of this piecewise function. The last one that was asked for was number 17. Number 17 is not a piecewise function, it's just a single function. And it said to graph by using a table. So I'm going to be putting in lots of points on this table because there's no restriction on my x. So I'm going to use -4, -3, do all of that and plug them into this function and graph those points. So I plug in -4 and I get 24, and plug in a -3 I get 15. And I'm going to keep doing this, and I'm going to find the values for all of this. And now I'm going to graph those ordered pairs. Well, I can't do -4, 24 because my graph only goes up to 16. So I'm going to graph as many points as I could. I could have gone to I could have gone to +5, which would have given me a +15 as well, but I just stopped there. And now I'm going to, since I plotted each one of the points, and you can see the parabola that's going on there, and so I connect them, and even though it's a little bit wobbly, there is the parabola, and that's the end of problem number 17.